This is on the objective of being able to distinguish among sets of numbers, which is the ability to know the difference between natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers, and also to note the relationship between all these numbers. Also, this objective includes the patterns within numbers. Okay, so first off, we have natural numbers. These numbers are normally represented by an n for natural, and these numbers start at 1 and go all the way up to infinity. These are the numbers that we tend to use in everyday life. So as you can see, it starts at 1 and it keeps going all the way up to infinity. So it goes 9, 10, 11, all the way up to infinity. In case you didn't know also, this sign is the sign for infinity. Okay, so after natural numbers, we have something called whole numbers, which is denoted by a capital W. Whole numbers are all the natural numbers, including the number 0. So it starts at 0, 1, 2, 3, and just as before, it goes all the way up to infinity. Okay, so after whole numbers, there are integers. Integers are whole numbers that also has negative values. So as you can see in these whole numbers W here, they start at 0 and go all the way up to infinity. For integers, they start at negative infinity and go all the way up to 0. And then they go all the way up to positive infinity. Okay, so afterwards we have something called rational numbers. Rational numbers are denoted by the capital letter Q, and rational numbers are any numbers that can be represented as a fraction. Okay, so some examples of rational numbers are, for example, 0.75. 0.75 could be represented as a fraction by 3/4. Also, this number 2 here, that's a rational number, because 2 can be represented as a fraction by 2/1. So basically, a rational number is any number that could be represented by a set fraction. So another example is 0.6. This could be represented by 6/10, or 3/5. So all these are rational numbers. Conversely, now there are numbers called irrational numbers. These are numbers that cannot be written as a fraction. So an example of an irrational number is the square root of 2. If you actually put this value into a calculator, you'd get a number 1.4121, and it keeps going down. Like, there's no set final value. It always decrements to another number. So there's no way to actually represent this as a fraction. So this is an irrational number. Also, the ratio pi is also an irrational number, as the decrementing decimal places There's no actual finite value for it. It's just a ratio. Okay, so now how these numbers relate to each other. So if you recall, there were natural numbers denoted by n. There were whole numbers denoted by w. There were integers denoted by z. There were rational numbers denoted by q, and also there were irrational numbers. Instead of defining a symbol for irrational numbers, we could use the union of real numbers. So real numbers denoted by r consist of all these other types of numbers as well as rational numbers. So to properly define this, we use the symbol that looks like a C. So this symbol means that it's a subset of. So actually using this, we could say that natural numbers is a subset of whole numbers, and whole numbers is a subset of integers, and integers is a subset of rational numbers. Rational numbers is a subset of rational numbers is a subset of real numbers. So what this basically means is that all the natural numbers, which starts at 1, 2, 3, 4, all these numbers here is included into here. So whole numbers, if you recall, it's actually starts at 0, and then it consists of all the natural numbers. So similarly for integers has all the whole numbers, also their negative values. So it starts at negative infinity and goes all the way to positive infinity. Q, which are rational numbers, any numbers that could be written as a fraction, so any number a over b. And real numbers are all these numbers here, included rational numbers. So this could be termed as all the natural numbers plus the whole numbers plus integers plus rational numbers plus all the irrational numbers. Okay, so now we're going to talk about multiples. So a definition of this is multiples of any number n are the results of multiplying n by a natural number. Okay, so an example of this is if you take the number 2, a multiple of 2, if you multiply this number 2 by any natural number, you'll get a multiple of 2. So if you multiply 2 by 3, you'll get 6. 6 is a multiple of 2. If you multiply 2 by 8, you'll get 16. 16 is a multiple of 2. If you multiply 2 by 100, you'll get 200. 200 is a multiple of 2. Next we have even numbers. Even numbers are any numbers that could be divided by 2. So even number could be 2, 4, 6, 8, 10, and go on until you reach a very large even number. So basically how you could look at this is any number that is a multiple of 2. So 4 is a multiple of 2 because 2 times 2 is 4. 6 is a multiple of 2. 2 by 3 is 6. 8 is a multiple of 2. 2 by 4 is 8, and similarly 10. And this could extend for every other natural number multiplied by 2. Odd numbers are the exact opposite of even numbers. They are numbers that are not multiples of 2. So whatever numbers are left over from this sequence here, those are odd numbers. So 1, 3, 5, 7, 9, 11, 13 onwards. Okay, so now we're going to talk about factors. Factors of any number n is the exact divisor of that number. So what this basically means is, for example, if you have the number 12, factors of 12 could be 1, 2, 3, 4, 6, and 12. So what a factor is any whole number. So what a factor is, it's any number that could be divided exactly into another number. So factors of 12 again are these numbers here. And if you take 12 and you divide it by 12, which is this last number, you'll get 1. If you take 12 and divide it by 6, you'll get 2. If you take 12 and divide it by 4, you'll get 3. If you take 12 and divide by 3, you'll get 4. 12 divided by 2, you'll get 6. So again, factors of n is the exact divisor of n. So factors of this number n here is any number that could be divided into it. Lastly, we have something called prime numbers. Prime number has exactly 2 factors, and those 2 factors being 1 and itself. An example of a prime number is the number 2, or the number 3, or the number 5, the number 7, and it keeps on going up. So you just have to look at the factors. So for example, the factors of 2 would be 1 and 2, and from the definition, prime numbers has exactly 2 factors, 1 and itself. So 1 could go into 2 and 2 could go into 2. Alright, so 3, only 1 could divide into 3 and 3 could divide into 3. 5, only 1 and 5. And well, this goes on. Similarly, there is something called composite numbers. Composite numbers are any natural numbers with more than 2 factors. So for example, that we used above, 12 has the factors 1, 2, 3, 4, and 6. So the number 12 is a composite number because it has more than 2 factors. This actually has, and 12. So this actually has 1, 2, 3, 4, 5, 6 factors. Which is more than the requirement for prime numbers. So prime numbers is only 2 factors, 1 and itself. And well, composite numbers is any natural numbers with more than 2 factors. Okay, so now we have square numbers. So a square number is the result of multiplying an integer by itself. So the square number is, if you take any number a and you multiply it by itself, you'll get the squared result of that. So for example, if you take the number 2 and multiply it by itself, you'll get 2 squared, which is 4. If you take the number 3 and multiply it by itself, you'll get the squared number of 3, which is 9. If you take 4 and do that, you'll get 16. And so on and so forth. It goes all the way up. So if you take number 7 and multiply it by itself, you'll get 49. So all these are squared numbers with so all these numbers are the squared version of these numbers here.